We're going to be talking about medians of triangles today. A median, not to be confused with a midsegment, okay? A median of a triangle is a segment from a vertex to the midpoint of the opposite side. So I'm going to start my construction with a triangle. And if I wanted to create medians, I'm going to need midpoints because median is a segment from the vertex to the midpoint of the opposite side. So to create a midpoint, we go into our point menu. If I hold down, there's our option for midpoint. And I'm just going to click on the two endpoints of my segment for which I need the midpoint, here. There's three sides to my triangle, so there's three midpoints that we could then find, which would mean how many medians would a triangle have? Hopefully you think three, right? Because there's three vertices that you could join with the midpoints of the opposite sides. Now you're going to notice something as I'm creating these medians. What do you notice? Something that we've been noticing with a lot of these segments in our triangle is that they are concurrent. They are all intersecting at one point. Now, the one point of intersection of all the medians of a triangle, this is of the medians, is what we call the centroid. Okay, this is my centroid. The centroid's pretty neat because the centroid of a triangle is actually the center of gravity of the triangle. And this centroid has, there's a relationship with the distance from the vertex to the centroid and then the centroid to the side of the triangle. So I'm going to measure to see if we could find that relationship. So if I'm looking for a measurement, I think right there. Okay, so let's measure this distance from the vertex to this centroid and now the centroid to the side of the triangle. Decimals, it's kind of hard to see, so I'm going to manipulate my triangle and hopefully make this a little bit easier for you to see. I can't move that guy. Let me move them all around. Hold on. Let's move this down a little bit. I'm trying to make it easier. You can see I'm almost there at what I want it to be. There it is. Look at that. Boom. There it is. Okay. Look at, we've got 6 and we have 3. Okay. So the distance from the vertex to the centroid is 2 times the distance from the centroid to the side of the triangle. Now, if you think about that as a ratio, okay, if my distance from centroid to the side of the triangle is 1 part, then the centroid to the vertex is 2 parts for a total of 3 parts, right? That means that the distance from the centroid to the side of the triangle is 1/3 the length of the entire median. And the distance from the vertex to the centroid is 2/3 the entire length of the median. So let me put that in words to kind of help you see what I'm saying, okay? So this is a theorem which is called the concurrency of the medians of a triangle, and it says the medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay? And remember that the median starts at the vertex, goes to the midpoint of the opposite side. Here we can see those relationships with our equations. AP, which is the distance from the vertex to the centroid, is 2/3 of AE, which is the entire median. And so on and so forth with your 3 medians. So here's an example of what I'm talking about with the 2/3, okay? If I know that SQ is 8, I'm asked to find the length of QW and the length of SW. Well, just from our demonstration in GeoGebra, right? We saw in GeoGebra that if this was 6, this was 3. The length from the vertex to the centroid is 2 times the length from the centroid to the side of the triangle. So to find QW, if SQ is 8, QW is half of it. So QW should be 4. And then SW is the entire median. Well, we can add and see it's 12, but we can also verify that 8 times 2/3. No, that's not what I want. 2/3 times 12, which is the length of the whole median, should equal 8, which is the length from the vertex to the centroid. And let's see if that works. So 2/3 times 12 over 1. So we reduce, cross cancel I should say, and this is 4. 2 times 4 is 8, right? So that means that SQ is 2/3 of SW. We know that. All right. We also know that 2 times QW should equal SQ. Just a few different ways that you could actually see that set up for the relationship with the medians and the centroid.